My name's Rich Groves. I'm a principal architect here at A10. I know some of you from my days at Microsoft, and Rob Sherwood just texted me to let me know that he put a picture of me up at another one of these presentations earlier. So I think I'm not really sure whether I have the only honor of being pictured twice on Network Field Day in 1 week. But I'm very happy about that. All right, so I'm not going to talk a lot here. We want to get to the question and answer period. We're going to show a demonstration of DDoS mitigation with balls. So there we go. What we're going to talk about right now is this particular device here. So this is the A10 TPS, the threat protection system. It is a purpose-built DDoS mitigation platform. Really large hosting providers, web giants have come to us because they're getting DDoS, obviously, right? We see that in the news all the time. And the DDoS traffic is actually growing exponentially, and so they need a platform for that. So this device has, the user has a choice of mitigating in stateless or stateful sort of mitigation, right? So the last thing that you want is your DDoS mitigation appliance to actually go down under load. And so we've taken a very interesting look at deterministic performance on the box. I mean, I know that from a user's perspective, I really don't want. I might differ a little bit from Mike's message here. I have no desire for a God box, just because of the scale that I'm used to working at, like at Microsoft and other places. So we need to make sure that whatever we put in for mitigation actually runs in a deterministic state. Protected objects, not VIPs, like we said, stateless, not necessarily stateful, although we do have some mitigations for that. The strategy itself is multi-level. So we have our TPS system, which is essentially the front door to the network. Then we have A10 services. We have a whole bunch more than that, as Raj and Mike pointed out. But these are more stateful services that we can involve in the DDoS mitigation service chain. We have network control plane interaction for making sure not only to suck traffic toward our box, but to make sure that if there's a DDoS that can be mitigated in the network, if it makes sense to be mitigated in the network and there's resources, that we should be able to do that.
Doing things like remote trigger black holing, flow spec, stuff like that?
That sort of thing, yeah, that sort of thing.
Because, 100 gig plus, I got to push that upstream somewhere.
Yeah, that's right. And network devices like routers and switches are really good at dropping packets. That's what. So we can make them drop packets without a problem.
One way to look at it.
So the design goals for the threat protection system, we wanted to provide exponential mitigation capacity per rack unit. I know putting in the incumbent, I used to have to work with them all the time, that in essence we do in one rack unit what they do in, let me think, 12 rack units. Expose all the knobs possible for expert configuration. Like Mike was talking about through the API, that's totally important. But some definition of DDoS mitigation or a DDoS itself may be different for some companies. I mean, we can have some canned definition of DDoS mitigation or of a DDoS that we have to mitigate, but it's not true all the way around. We want to provide deep statistics or even statics, like I put up there. I'm not sure why it's statics. And deliver those stats in a scalable way. Raj talked about our stats library, where we count everything really on the platform, and we keep those statistics. And we've been doing that forever in ACOS. So we want to expose that. CLI and API configuration parity, of course, we talked about that. And then sort of wrapping it up with templates to abstract the complexity if the user who oftentimes comes to us and says, I don't know what to protect me from, just protect me. And that That's important. I only have 2 slides, by the way. I accept applause. So, or bitcoins for that matter. So we have deployment options. There are a whole bunch of them. They're growing essentially every day. Asymmetric reactive, this is sort of the state of the industry, collecting telemetry from the network. We decide that there's some DDoS that's happened. Traffic redirection happens through our API. We suck traffic toward ourselves, and we're like the path of greater scrutiny, more than just DDoS mitigation, right? Because we have our DPI capabilities. We can actually look at the traffic that's passing. Symmetric, we're going to demonstrate that today because just for ease of demonstration. Otherwise, there are lots of spinning plates that we have to actually have in the air for the demo. That acts as a gateway. Asymmetric proactive, we actually really shine in this manner because with a platform that can mitigate DDoS at 160 gigabits per second, we can actually make that model scale where we announce your high dollar targets from the mitigation appliance, and we look at the traffic coming inbound, not needing to look at it outbound. We have counterpolling that happens on our box really fast, so second level and sub-second level, so that we can, and then with the shared memory architecture, any traffic that hits any core, we can do instant correlation on that time series data. Out of band, as some of you know, I'm the daemon guy from Microsoft, so I wanted to make sure that we had the ability to sit off of a monitoring network like BigTap, so that we could do this sort of threshold violation, anomaly detection off of one of those systems too, and we can make that scale. And finally, we have a deployment model that we call Arista Direct Flow Assist, where we either event to an Arista platform or we use events on our platform to trigger direct flow interaction. The beauty of this particular one, in my opinion, is that we start having the ability to carve up the box so that we have some interfaces that run in tap mode, where we receive this data promiscuously, and have the ability to then use direct flow to tell the, those are 70, well, I don't know. I can't tell what they are actually. To tell the EOS boxes up north to send traffic across our mitigation data plane. So you can have it do both things and carve it up at the capacity that we have.
Question actually, I don't have a background in DDoS that much, but so for the symmetric and anything in line, are those just transparent boxes that sit in between, you get internet router, firewalls, sort of?
They can be deployed that way. They can also be deployed in L3 mode, so it acts as your L3 gateway as well.
Got it, okay.
So now we're going to break into the demo. We're going to talk about really, the sort of, because of time, we're probably going to stick to the CLI a lot of the stuff that we've already seen. But we're going to mitigate a very large SYN flood attack, mitigate at the same time this low and slow attack that generally happens both at the same time. One of them to sort of poke the eye out of the detection system, and then something that lays low and takes care of the other problems. I'm not really sure we'll get into the last two because of time constraints, but large-scale filtering of known bad actors. My favorite part of the platform, frankly, is with the with the shared memory architecture. I can have 8, in the current product, we can have 8 by 16 million line IP address lists that we can inject into the data plane, right? So this is enormous filtering capacity.
Where are those lists coming from, though, I guess?
There are definitely lots of lists that are just freely available on the internet. We have partners also that we have on the website as well. So making sure that we have the ability to look at open resolvers, have lists of open resolvers, reflection sources.
Some publicly available, some other licensed data sources.
That's right. Yeah, and it all sort of depends on what sort of error checking you really need in your data set so that Google doesn't end up in your filter list,
Yeah,
for
I mean,
example.
we've all been in this situation with some of the open lists and trying to get your mail, you get your MTA removed from it, or it can,
Yeah, you get screwed, right?
it's got to change.
I've gone through many a situation where I've had to do that for Hotmail, so I completely understand. So what my lovely assistant Taka is going to help us out with here is he's showing the Ixia UI. Frankly, I don't make enough money to even look at the Ixia UI, so it's just far too expensive. But so what we have here is we have a really large, as you can see, you might not be able to see, so I'll just tell you, 120 gigabit per second, both V4 and V6 traffic. So we have 40 million unique sources that we're pounding this box with, and so we could probably just go to the CLI at this point. So Taka's going to take us over to the TPS CLI. So that I can just show you the traffic coming inbound, and we'll see holy cow. You can see all the numbers that mean something to everyone. Okay, you get to see here, so we've got the first 20 ports on the TPS. Port 1 is your protected object or protected server in this demonstration. As you can see, 17, 18, 19 are the ones that are pushing traffic. The point to what I'm trying to show you here is bad traffic comes in, good traffic comes out. And if we could show the CPU utilization, I think that's actually pretty important. So everybody has worked on boxes that are under attack and go completely unresponsive. We made sure in this platform to work on that problem. And we actually have a software configurable way to increase the number of control CPUs if it's required.
I think that's an important point that we didn't really talk about. Is one thing that we did right up front was actually say, control plane and data plane are completely segmented. We're not going to try to basically overlay compute onto the for basically control plane onto the data plane processors, because if the box does come under load, you want to at least be able to figure out why. And so being able to have those resources on a separate CPU, and it ends up making for a very clean debugging session when your box is separate.
Yeah, no, absolutely. And then we provide all these debugging tools and even a flavor of TCP dump on the box to make sure that we're able to look at some of the traffic that's coming inbound, and it doesn't go absolutely nutty like a switch does with because they have these little tiny, puny processors. Even the really nice ones have puny processors in comparison to what we have here.
This is a TCP SYN flood attack?
It is.
And are you acting on behalf of the protected device?
We are, yeah. So we have our special hardware inside that's doing a SYN cookie exchange.
So you don't have to keep state then?
That's right. No, we're not keeping any state here.
But you do have to stay in line.
Well, I mean, in line in that we can do some level of certainly the SYN cookie exchange when we're in this particular deployment model, in the symmetric deployment model, for sure. We also have SYN auth, capabilities, SYN authentication capabilities when they're asymmetric. So we'll even if we're pulling traffic toward a TPS device in asymmetric mode, we can complete the three-way and whitelist somebody if they need to be. And so we don't have numbers on that up here, but
It's fast.
it's super. yeah. It's
So if you complete the three-way handshake, though, you will have made up the protected device's initial sequence number, which
Yes.
the protected device won't know what you did.
Well, what we end up doing is we'll do a whole slew of things, but one of the things that I can mention for sure is that we'll reset the connection, just like many other people do the same thing, right? So that we'll reset the connection and then let it pass through the next time through.
I see.
if you have to.
And then that IP address is whitelisted because you know it's
That's
a real
right.
client.
That's right.
I see.
That's
Yeah,
right.
we're not doing a state transfer, like that once that ISN is generated, we're not sending that back to the client through some outbound method or anything weird like that.
Here's the ISN you used.
Exactly. It's as Rich said, it's just, we're using the properties associated with the protocol and take advantage of certain properties of the protocol to actually gather intel so that we can actually say, you're behaving correctly or you're not.
I see.
Yeah. So finally, we'll probably just end it on this one here, right? So what we're demonstrating here is a slow LoRa's attack. So just to make sure that I give you a background on that, it's actually pretty simple. So you can spin up a whole lot of HTTP speakers. They'll send partial headers very slowly to keep sockets open. And eventually servers roll over, and it's not visible in this volumetric scenario. And so a lot of people, a lot of products actually don't even detect these sorts of problems. What Taka is showing us is that we're under this inflow attack still. We haven't stopped the Ixia, but we're using Pylorus, you can download freely, to attack our web server on the other side. The first two, you can see the number of packets processed for the HTTP parser and the number of partial headers. I don't really have a good demonstration of this otherwise, but you'll have to use your imagination at the moment. So that's really it. For the sake of time, we'll probably just stop here. Thank you very much, and I wanted to open it up to questions and ask Mike and Raj if...
Just something on the DDoS stuff while we're sort of talking about it and whatever. One of the challenges that I see in the ISP market is a lot of very short targeted attacks.
Yeah, we see the same thing.
Basically by 15-year-old kids trying to make their mates get lag for just a little bit so they can knock them out in whatever game they're playing. One of the challenges I've seen with other tools and things we've tried to use to mitigate that is that we don't want to step in and act too quickly. There's a balance between how quickly can you detect this is bad versus, sometimes particularly if you're doing traffic anomaly detection. Right. It's not like it's a specific signature or anything like that I'm looking for, but I'm looking for those shifts. And so, it's just so interesting. Like, what are you seeing, and how quickly can you pick those sorts of things up?
So what we it was important for us to reduce the mean time to mitigation. Actually, that's why we even got into the market, right? What we're seeing at our large customers is this sort of pulsing DDoS attack where people come in at maybe 15-second intervals and completely saturate a host or saturate a service or even saturate the whole network. And unfortunately, those of us who have run cacti in the past have no way to really know over a 5-minute smooth average. And so that's why we're involved. The asymmetric proactive deployment is really popular for our platform because of that second and sub-second level polling of counters.
Because even like 15 seconds, say like if I'm using, say, a flow-based solution and I'm expiring it, I've got an active expiry timer of, say, 15 seconds.
Yeah,
which is
good
pretty
luck,
common
right.
recommendation. It's like, so it takes me a minimum of 15 seconds to start getting those out to my flow collector, which has then got to process them, do something. And the attacks.
Yeah, like we've seen anywhere between 2 and 7 minutes for that sort of detection in the flow space. So adding a box like ours, and one of the cool things that I didn't actually mention here, so thank you for this question really, is that we can take up to 8 of our boxes right now in the current product, and we can synchronize our whitelists across them. So it's like a pseudo cluster, essentially, of 8 boxes that we're showing here.
So if I was a distributed ISP or something, multiple pops, I could sync those across between different pops as well.
Yep. Yeah. So that we can whitelist, and we don't have to challenge the end host, every time they come through because of being ECMP sprayed across my my DDoS mitigation boxes.
By the way, we're not going to go through it, but we'll just put the UI in the background just so so folks can actually
Yeah,
see it.
it exists. We just didn't play with it for sake of speed.
Old habits are hard to kick. So.
Have you changed your authentication on the new UI? Because it was previously a pop-up auth box with a unique domain, a unique authentication.
Yeah, so 401 would be, take advantage of the fact that the browser would, pop something up and then you auth, right? So with moving to a new the new Django framework, we actually have forms now that we're using versus actually just the pop-up. So it looks a little bit cleaner, right? There's a better look and feel. The new UI is going to be based off of, again, Angular, JS, and Django, and a little bit of Bootstrap here and there. And to your point, we're actually, getting a haircut. So
how does that? Because right now with AX API, that's you have to go through the fun of authenticate, get a token, get a key back, and then every request has to submit that key back in the URL. So is that disappearing as well?
No, that
can
doesn't.
we just put auth parameters in the HTTP headers? Or
So actually, that's the way that works, right? So
that's going to continue that way.
yeah. So what happens is that before you would, our legacy API, you would have a session ID you would dump there. Now you actually have an auth header that you can again distribute and share as you feel freely. You go in there and you actually take a different API path, right, for the UI. And basically the API itself. One of the things that we had to realize is that as the majority of our customers that we deal with, because we're really big in the service provider space, they automate the stuffing out of everything, right? And so as a result, we have to not only have a high rate, but also be able to a high rate of change, but also be able to deal with some distributed applications that may be managing our platform. So moving to a full Helios hypermedia compliant REST API that behaves and functions like other standard REST APIs with JSON data structures is really kind of the path, and that's something a developer will be very comfortable with this with our API environment.
That was an awesomely geek-laden sentence. Thank you.